Hello and welcome to today. What we're going to do right now is we are going to correct the assignment that you guys were just working on. And this assignment is 2 through 16 even, 25, 26, 27, and 30. So we're going to quickly go over these. All right, I like to do things very systematic and similar, do things the same way all the time so that I get in the habit. So what I do with scientific notation, if I have to put this in scientific notation, the first thing you need to do is find a number bigger than 1 and less than 10. Okay, that's my first job. So in this big number right here, 1,304,000,000, I am going to put my decimal in a place. So I'm going to put it right here between the 1 and the 3. So it becomes 1.304. The second thing I need to do is write times 10. So that's what I'm going to do right now is write times 10. And the third thing I need to do is find out how many places you moved the decimal. So how many places did I move the decimal? Okay, so I'm going to count from this decimal, and I moved it. So remember, the decimal's at the end of the number here. So how many places did I move it from the end to put it between 1 and 3? So I start right here at the 1, 3, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm moving to the right. This is a big number, so I have a positive exponent of 9. All right, number 4. Number 1. Put the decimal where I need it to be. So it's going to go right here between the 1 and the 3. Interesting. Same kind of number here. So 1.33. That number is now bigger than 1 and less than 10. Step 2, write down times 10. So here I go, times 10. The third thing is how many places did I move that decimal? So I'm going to start where my decimal is. 1, 2, 3, 4. And that becomes my exponent. Number 6, put that decimal in there. So let's see, I need it between the 3 and the 8. So it's 3.84. Step 2, write times 10. Then how many places did I move the decimal? 1, 2, 3, 4, 5. That becomes my exponent. All right, on 8, 10, and 12, we're doing the exact opposite way. It's already in the decimal. So they want me to move the decimal however many places that exponent is. And so this one, it's 9, and because it's positive, I'm going to the right. So start here at your 8, 1, 2, 3, 4. So 1. Then I have 1, 2, 3, 4 places, 5, 6, 7, 8, 9. Okay, I have now moved my decimal 9 places, and I'm going to go back and put my commas in so that this becomes a number. Number 10, I need to move it 7 places. So just writing the 8, I haven't moved my decimal at all, but I move it around the 4, that's 1, around the 5, that's 2, around the 6, that's 3, 4, 5, 6, 7. Then put my commas in to finish off. All right, so I need to move this decimal 10 places. Well, right here, the number is at the end of the 9, so there's no number to get around. So that means I'm just going to put down 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you count, there should be 10 zeros in there. All right, number 14, the town recycled 7.6 times 10 cans this year. Write the number of cans in standard notation. So I have my 7. I'm going to go around the 6. That's 1, and I have to move it 6 places. So I moved it 1, 2, 3, 4, 5, 6 places. And go back in and put your commas in. All right, number 16, I believe, is the next problem that we were assigned to do. So on number 16, they want us to write this in scientific notation. So looking for this is this number right here. Remember, rule number 1, go put the decimal so the number is between 1 and 10. So 6.6. Step 2, write times 10. Now, how many places do I have to move it to get to the end of this number? 1, 2, 3, 4. That becomes my exponent. Number 25 and 26. So during a discussion in class, Sharon learns that a birth elephant weighs 230 pounds. In 4 herds, about 20 calves were born. So how much do these weigh all together? Okay, so if we're going to find out, so if one of them is 230, we are going to take 230, and there's 20 of them all together. So we're going to take 230 and multiply by 20, and we get 4,600 pounds. Now, they want this in scientific notation. So remember, we're going to put the decimal where it needs to go first. So 4.6. Step 2, write times 10. Then how many places do we move that decimal? 1, 2, 3. So put a 3 up here as your exponent. All right, 26. Which of these numbers are in scientific notation? Well, the first one, that is not a number between 1 and 10, so that doesn't work. This one looks okay. Numbers between 1 and 10 times 10, that works. Number between 1 and 10 times 10, that works. Number between 1 and 10 times, oh, that says times 5 to the 10th, so that one does not work. All right, and then on this page, I think we had number 27. So Polly's parents' car weighs about 3,500 pounds. Samantha, Esther, and Polly each wrote the weight in scientific notation. Polly, Sam, and Esther each wrote. So which of these girls is correct? Well, let's check out all 3 numbers. Is this first one in scientific notation? Nope, because that says 35. This number right here needs to be 1 and 10. All right, Sam wrote the second one here. So again, is that number between 1 and 10? Nope, so that's not good. And Esther wrote 3.5 times. Okay, so this one's actually in scientific notation, but is it correct? So let's just double check. So if we have 3,500 pounds, remember rule number 1, put the decimal where it needs to go. So this would be 3.5. All right, that's what Esther wrote, 3.5. Then we write times 10. Now let's see, how many places did we move the decimal? 1, 2, 3. Is that what Esther has? Nope, she has a 4. So are any of these correct? No. Explain mistakes. Well, first 2, whoops, TWO. First number, not between or bigger than 1 and 10. It's not bigger than 1, less than 10. Okay, then the last girl, Esther, wrong exponent. So Esther, wrong exponent. All right, moving on. I think we had one left after this. So let's see. All right, compare the 2 numbers, which is greater? Well, let's see. Exponents. Which one's bigger? This is 2 place values bigger, so this is going to be your bigger number. All right, now we are going to move on to the new lesson for the rest of today. All right, the rest of the lesson for today is your learning target is going to be, I can write a very small number in scientific notation with negative exponents. So everything we've been doing so far have been really large numbers with positive exponents. So now we're going into lesson 2-3, and I'm just going to go right to it. So if you look here, we have a very large number, which is what we just corrected. Okay, and the rule was, first, go put your decimal where it needs to go so that the number is bigger than 1 and less than 10. So in this case, it would be 2.241? 2.241. All right, then second step, write times 10. And the third step is we put this decimal between the 2's right here. So now we moved it 1, 2, 3, 4, 5, 6, 7 places. That becomes our exponent. Okay, what we're going to be doing today is dealing with very small numbers. And the very small number would be something like this. See how we have the decimal value here? Well, the rules are exactly the same. Okay, so a single monarch egg is going to weigh as little as 0.00046 grams. That is very, 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 very tiny. So what would that be written in scientific notation? Well, the rule is exactly the same. This first number right here needs to be between 1 and 10. So let's go put that decimal where it needs to go. So in this case, it's going to be 4.6. Rule number 2 is still the same, right? Times 10. Now start at your decimal and count how many places. 1, 2, 3, 4 places to get to that. Now, which way did I go on a number line? So on a number line, when we go this way, we have positive numbers. But when we go left and we go this way, this goes towards negative numbers. And which way did I go? To get to that decimal, did I go left? Do I have a very small number? So this exponent is going to be a negative 4. That's the only difference. Large number, positive exponent. Small number, we're going to have a negative exponent. Okay, so that's the big difference between 2,2 and 2,3 and talking about the numbers and how we write them in scientific notation. All right, so here we go. We're just going to practice a couple. So we have a very tiny, tiny number, 0.000829. So rule number 1, put your decimal where it goes. Okay, so we have 8.29. That number is bigger than 1, but less than 10. Then we write times 10. Now find out from where I have this decimal, 8.29. Move it 1, 2, 3, 4, 5 places. And because we went left, and this is a small number, we're going to have a negative 5 exponent. All right, number 5, go put that decimal. So I know we already have a decimal in here, but to put it in scientific notation, remember there are 3 very specific rules. And the first number is bigger than 1, less than 10. So we're going to put this decimal right here, 3.02. Second step, write times 10. Now we have to go figure out what that exponent is. So start at the decimal that you just put in the number and count 1, 2, 3, 4, 5, 6, 7. We get smaller, smaller, smaller. So that is a negative 7 exponent. All right, in this one, so put your decimal. Well, let's see, it's right here for a tiny number, but we have to put it after the 7. So this becomes 7. Then write your times 10. Now start where you put this decimal and count 1, 2, 3, 4, 5, 6 places to get where it was originally. And that's a small number. So it is a negative 6 exponent. All right, I just want to go through 2 things, big numbers, small numbers, and how the rules are exactly the same. So we're going to put this in scientific notation. Put the decimal where it needs to go so that this number is between 1 and 10. It doesn't matter if you have a big number or a small number, that is the first step. So we're going to put it right here, 7.821. So whether we're dealing with big numbers or small numbers, that's always your first step. Then we write times 10. That's always your second step. Now count. Here's where I put my decimal. So count 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Really big. Move to the right. So that is a positive 9 exponent. Okay, put the number here. So now I'm going to count 1, 2, 3, 4, 5, 6, 7 places. Really small number, moved it to the left. That's a negative 7 exponent. All right, so if it's in scientific notation, how do we put it back into a standard number? Well, if you look here, this is a positive 8. It's saying, hey, move the decimal 8 places. So I have to go 1 place around the 2, 1 place around the 1. So I moved it 1, 2. Now 3, 4, 5, 6, 7, 8. We always fill the rest of the numbers in with zeros. And then because this is a big number, we're going to go back in and put our commas in there. And the last one here. So we have to move the decimal 5 places. And because it's negative, I'm going left. So it's 1, So here's 1, 2, 3, 4, 5, and put your decimal. All right, good luck.